Hello and welcome to another lesson on probability. Today we will talk about random variable and probability distribution. As you know, the outcome of a random experiment need not always be a number. For example, when we toss a coin, I may get head or tail, but very often we need to associate a number with such outcomes. That is, there is a need to quantify the outcomes, and that is where we bring in the idea of random variable. Random variable acts as a real valued function which associates a real number to an outcome of the sample space. So, the formal definition of the random variable is random variable is a real valued function that associates a real number to an outcome of an experiment, and therefore, the domain of this function is the sample space of the random experiment. Let us look at two possibilities. If a coin is tossed 10 times, then the random variable will take the values which are same as the number of tails that are obtained. So, x can take values from 0 to 10. If I have a light bulb which is burned until it burns out and random variable y represents its lifetime in hours, then y can take any positive real value. There is a difference in the two examples, which is what decides the classification of random variable as a discrete random variable, where the values that random variable take are countable. So, 0, 1, 2, 3, 4 etc., whereas continuous random variable is the one which takes an infinite number of possible values. So, our first example where a coin is tossed 10 times, the random variable x, which represents the number of tails, which counts the number of tails in the outcomes, takes values 0 to 10. So, it is a discrete random variable, whereas where y represents the lifetime in hours, y can take any positive real value, and that is continuous. For our discussion, as in grade 12, the random variable will always be the discrete random variable. Now, suppose I have a coin tossed 3 times and the sample space results as this set with 8 possible outcomes. If x is the random variable defined as number of heads obtained, then obviously x takes the value 0, 1, 2 or 3. So, that means I can have no head appearing, or 1 head, or 2 heads, or 3 heads. So, associated with the outcome HHH, x associates the real number 3, with 3 outcomes HHT, THH, HTH, x associates the number 2, and similarly the number 1 and 0 gets associated with the respective outcomes. But the moment I change x from this definition to the definition of defining number of tails obtained with the same sample space, number of values that x takes remains 0, 1, 2 and 3, but now 0 gets associated with HHH, where in our earlier case it was 3 that was getting associated. So, now x is counting number of tails, and therefore, HHH gets associated with 0, and correspondingly there is a change in other outcomes. At the same time, each of these random variables can be associated to their respective probabilities. Let us consider what that would be. So, if I have a fair coin tossed 3 times, results in this sample space, and we look at x to represent number of tails obtained. X takes the value 0, 1 and 2 and 3. If I want to find the probability of x equal to 0, it is same as saying probability of getting 0 number of tails, same as saying 1 by 8, because the 0 tails means HHH, getting 3 heads, and that probability is 1 by 8. At the same time, probability of x equal to 1 would be getting one tail, and you know that that is same as 3 by 8. Getting two tails is probability of x equal to 2, which is again 3 by 8. Probability of x is equal to 3 should be same as probability of getting 3 tails, which is same as probability of x equal to 3 coming out as 1 by 8. So, corresponding to the random variable x, which denotes the number of tails, that is x takes value 0, 1, 2 and 3, we count out the probabilities of each one of them. If I put this together in a tabular form, I get what is called as the probability distribution of the random variable x. So, probability distribution is nothing but a representation of this information in terms of graph, table or formula. More formally, we define probability distribution of a random variable x as system of numbers, x taking value x1, x2, x3 up to xn, which are the values of the random variable. P of x is the corresponding probability. So, Pi represents probability of x equal to x of I, and that is what is referred to as a probability distribution. Now, once we have this statistical data with us, there are two quantities that are associated with it, one known as mean of random variable and the other variance of random variable. So, what is mean of a random variable? If I have x as a random variable with possible values x1, x2 up to xn with corresponding probabilities p1, p2 up to pn, then mean of x denoted by the Greek letter and read as mu is given by summation of xi pi I varying from 1 to n. If you had observed earlier, sigma pi, the summation of the corresponding probabilities pi will always be 1. So, it is same as sum of observations divided by the number of observations. At the same time, mean of x is also understood as the weighted average of the possible values of x, where each value is being weighted by its probability with which it occurs. We also call it expectation of x. So, E of x is same as mu, that is summation of xi pi, summation running over 1 to n. Another quantity that is associated with this probability distribution is variance of a random variable. Variance of a data is nothing but the measure of dispersion of the spread of the random variable around the mean, and variance in this case is given as in any other situation, summation of the square of deviation of each value of random variable from mean. So, xi minus mu whole square times pi. Summation of this gives us the variance, and it is read as either variance x and written as VAR of x, or the standard notation symbol is sigma, the lower capital, not the capital letter, but the lower letter of the Greek alphabet, sigma square, and x as a subscript to indicate that we are finding variance of x. Mu remains same as our mean, but this at times becomes cumbersome to calculate. So, on simplification, the formula takes the shape of expectation of x square minus square of the expectation of x. So, you do not find the deviation of each random variable from the mean independently, individually, and then square and then multiply by pi. We will use this formula where expectation of x square is nothing but summation of xi square times pi, where I varies from 1 to n. Along with this, we also have standard deviation. Standard deviation is nothing but the positive square root of the variance. So, you calculate variance and you take the positive square root of it. That gives us another measure known as standard deviation of a random variable. Here's a question for you to follow with so that these definitions and formulas make more sense. The problem states that find the mean and variance of the number of sixes in two tosses of a die. So, here we are talking about mean and variance of a random variable. So, first let us define what a random variable is. Let x be the random variable defined as number of sixes. So, how many sixes can I get? When I roll a die twice, then either I can get a 6 on both the die, that means I can take x as 2. I may get 6 on one of the die, so x can take value 1, or 0 when both the die do not show a 6. So, x takes the value 0, 1 and 2. What we now need is the corresponding probabilities. First, we know that probability of getting a 6 in a single throw is 1 by 6, not getting a 6, 5 by 6. So, what is the probability of x equal to 0? That is, I get not a 6 and not a 6. So, a not getting a 6 is 5 by 6 as a probability. So, 5 by 6 into 5 by 6, 25 by 36. Also note that when we say probability of x equal to 1, so I can get a situation where first die shows a 6, second does not, or the first does not and the second does. So, it has to be 1 by 6 into 5 by 6 plus 5 by 6 into 1 by 6, resulting as 10 by 36. Similarly, we get probability of x equal to 2. Once I have these probabilities, we are ready to give the probability distribution as this table. As a check, always calculate the sum of the probability and ensure that it always adds up to be 1, right. And now we are ready for calculation. What is xi times pi? Correspondingly multiply the entries. Also, since I need variance, I will calculate xi square times pi. So, just again multiply the previous calculation with xi. We need to find the mean, which is summation xi pi. In this case, add all the entries there, and that is nothing but 12 by 36, same as 1 by 3. Standard deviation and variance comes a little more elaborate. Variance of x in this case is expectation of x square. So, you have the again sigma xi square pi, which adds up to be 14 by 36 minus square of the mean, which is 12 by 36 square. Simplify and you get variance as 5 by 18. So, this example illustrates how to calculate mean and variance of a certain random variable. What you have done right now is simple calculation, but you do need to have a clear understanding of the basic rules of probability. We will continue with more on probability distribution in our next lesson. Thank you.